So on our extra credit, problems 1 and 2 are pretty much the same problem. And on problem number 1, if you don't list out every step, really all you need to find on problem number 1, I gave you some steps. It's kind of an alternative way of going about finding that answer. It's doing a present value compound interest adjustment rather than just using the formula. Number 1, all you really need to find is the monthly payment. During the accumulation phase, which is all you're trying to find in problem number 2 as well. Those two are really pretty much the same problems as number 24 and number 25 on the test. So I leave them to you guys to play with and see how you can do. Number 3 is where I started having a little bit of fun with it. So let's take a look at number 3. Now, obviously, I'm not going to do number 3, so I'm going to change the numbers and change the name in an example very similar to this. So we're not going to talk about Jeannie, we're going to talk about Christine. And Christine just inherited a large sum of money from her aunt. So we're just going to put down inheritance. We're going to say Christine is now 25 years old. Hopes to retire at 65 and plans to be dead at 90. Yeah, I know, a tactful way of putting it. Now remember, for number 3, we said plans to live until 88. So that's not in number 3, but you have to pencil that part in. While investing, Christine feels she can earn 9%, and that while drawing out, will only be earning 4%. Now, of course, we can do the math here to get 40 years on this side and 25 years on this side. What Christine wants to know is if she would like to draw out $3,600 a month in retirement, how much does she have to put away right now? This problem, the first half of this problem is identical to problems 24 and 25 on the test. It's the second half that becomes very, very different. So our first half here, we're still going to take the 3,600 times our 3 parentheses. What's going to go in the parentheses? 1 plus 0.04 divided by 12. I'll help you with that. 300. 25 times 12 is 300. Then what?
Minus 1, close parentheses, divided by, open parentheses, 0.04, divided by 12, open parentheses, 1 plus 0.04, divided by 12, close parentheses, for each of power 300, close parentheses, close parentheses.
Perfect. So now I'm going to punch that one in. Hopefully that all entered correctly. Do you get $682,028.94? let you guys confirm that. Yep, that's what we get. Okay, cool. Now that is still the number that we start the second phase with. And we are still going to divide, but Christine is not going to make regular payments. Christine is going to take money out of her inheritance and put away one lump sum at age 25. So this is divided by 1 plus the rate, 0.09, divided by 12, because we're going to still assume compounded monthly, to the power of, well, 40 years at 12 months is 480 months. And that's it. It's just a present value of compound interest. So take that amount divided by parentheses, 1 plus 0.09 divided by 12. So 18,887.59. So at 25, if Christine puts away that $18,887.59, she should reach her goal of being able to draw out the $3,600 a month in retirement. So that is your roadmap for number 3. Anybody have any questions on what we did there?
480 was calculated by taking 40 times 12.
You got it.
Okay. And 300 was calculated by 25 times 12.
You got her. Perfect.
Got it. Just a few questions on lingo, Todd.
Yes.
So needs to set aside, is that equivalent to invest now?
Yeah.
Present value?
Yep. Set aside one lump sum right now, pretty much.
Okay. Annual fund sinking payment is equivalent to present value?
Does that put annual fund sinking payment in there?
No, the stupid quiz online did, and I didn't know what it meant.
Oh, the annual fund sinking payment is usually if you're taking out a loan and you're amortizing the loan payments.
Fair.
That's the same as the liquidation phase of an annuity and drawing it out. A sinking fund is the same as the liquidation phase.
Fabulous. And what's the difference between total interest versus earned interest?
Those are the same.
They are the same. I wondered that. And then, do you mind if we use scratch paper?
Nope, feel free.
Okay.
I know I didn't give you near enough room on here for this. What's that?
No, you saw my work. Are you going to keep the videos up after this class is over?
They will be posted on YouTube for as long as YouTube lets me. At some point, I'm going to reach a capacity limit, so I'll have to go back and wipe out old videos. Like this semester, I had to go back and wipe out videos from 2 years ago.
Okay.
So they should be up for at least a year.
That's a good window.
I didn't realize YouTube had a capacity limit.
Well, it doesn't have a strict capacity limit, but it slows down your connections. You start having problems uploading videos if you get over a certain amount. So when I start having problems uploading everything else.
That's so useful.
What's that?
Isn't there, I was just going to say, isn't there an alternative to like setting them as private? And would it improve your connections or no?
The problem with setting them as private is then you cannot access them without a link. And if I set them as private, you can, if you see one video, you can't see the next one. So I leave them like this so that once you get in YouTube, it actually should give you the list of all the videos for the class. You just go right down the list and you can see the playlist.
All right.
And also I do have people outside of the class that'll ask me questions on stuff and I'll just send them a link to one of my YouTube videos instead of going through the effort of actually answering their question.
All right.
And someday I'm going to put these together in some sort of a DVD that I can sell to people. And then I really will live on that hut on the beach.
I think you're only gonna have one guy buy them and he's sitting right next to me.
Yeah?
I'll buy the deluxe edition.
We want the outtakes too.
Actually, I do keep track of some of my, on YouTube, you can track how many views you've had and stuff like that. There's very few of my videos. Business math is one of the courses that I get the most views on because these formulas are kind of tough. So very few of my videos get more than about 4 or 5 views.
Wow, interesting. You need to do a blooper reel.
Yeah.
My last question, why did we do quizzes before homework every week?
Because the quiz was on the stuff from the previous week.
Got it.
You're really
Silly
smart.
monkey.
So let's do an outline for number 4 here. So we're going to talk about Pete, who is 26 years old and wants to complete saving for retirement by 40. Doesn't want to have to pay anything in anymore after 40. So what we've got is now Pete's 26. Wants to stop saving at 40. Wants to retire at 65 and plans to die at 90. I know. Plans to live till 90. Well, we'll put my sunshine spin on it. How's that?
It's not like you're saying he's born.
Well, that's true. So here we have 14 years, 25 years, and 25 years. Payment-wise, we know that he wants to draw out, I didn't say that up here, I'm going to say that Pete wants to draw out $3,500 a month in retirement. And Pete feels that in retirement, he can earn 5%. And while investing, he feels he can earn 10%. So both of these are going to be 10%, because technically those are both in the investment stage. Here, though, his payments are going to be $0. Here, we're looking for that payment. So this is going to take 3 stages. I sound really excited about that for some reason. So we start out with the $35,000 or $3,500 a month times 1, 2, 3, and what comes next? You got it. 0.05 divided by 12. Power of 300. And then minus 1. Close and then divide. Open and then this is just liquidation phase of an annuity. So 0.05 divided by 12 times another one. Perfect. 1 plus 0.05 divided by 12 to the power of 300, and then close and close. So I'm going to let you guys try to beat me to this. What did we get? Works for me. That's what I got. Any questions on that part? So that's just our pure liquidation phase of an annuity. Retirement, just like we've done so far. But here's the twist. From 40 until 65, good old Pete here wants to do nothing. Wants to just sit on the money. So this money is still going to start out our next phase. It's still going to be divided by. But it's going to be just a simple present value because there's going to be 0 payments made during that time. If there's no payments, it's just a simple compound interest. So 1 plus the 10% is 0.10 divided by 12 because we're still going to compound monthly, and then 25 years, so the power of 300. So we take that divided by 1 plus 0.10 divided by 12 to the power of 300. We get 49,656.87. That is the amount of cash needed at 40. If Pete has that much money in his account at 40, he can let it sit there and it'll give him the required amount at 60, which is the 598,000. But now we still have this 14 years to go back to age 26. So we're going to take this amount. We're going to start our next stage with it. And this is making regular monthly payments, so it is an annuity. We have a lump sum and we're looking for the payment, so we are dividing by 1, 2, 3. What goes in here? .10, yep. Yep. 14 years would be 168. 14 times 12, right? Minus 1, yep. And then? And then? Close and close, yes. I get $136.49 a month. Is that what you guys get?
$136.49, yes.
Perfect. Any questions on that one?
You go through those 3 steps to find payments.
Yep, that's how much Pete has to pay in every month from 26 to 40. Now let's talk about number 5, dear old Sammy.
Is it based on people you know?
No comment. Actually, if you look through my test, there are a lot of names that are people I know, like cities that are like Frank Tasia and stuff like that.
Yeah. Well, that's cool. I mean, that's what song is.
Sammyville and things like that.
Well,
So for number 5, I'm not going to bother to change the name because at this point in the semester, I totally lack creativity. We are going to change the age. Sammy is 26. And we're just going to put this in here. Now, retire and die. Sammy is now 26. Wants to retire. Let's say Sammy wants to retire at 66. Yes, I am purposely making my numbers easy in my examples for me. And plans to live until 91. So, what's going to happen here? Sammy thinks she needs to be able to draw out $3,500 a month in retirement, and thinks she'll be able to earn 5% while drawing out, and let's go 11% while paying in. We're going to change that percent a little bit. So now I can fill in. This is 40 years here. This is still 25, isn't it? There.
Pretty much, yeah.
Have a good night. The video should be up there before too long tomorrow. That one?
That was on the plate, yeah.
Bet. Here's the catch in this one. When Sammy retires, she wants to move. And Sammy figures at retirement she's going to use $30,000 to move. Now, of the twists I've done so far, this is probably one of the simpler ones. Because all we got to do is, when we get to the right time, add in that $30,000. Okay? So where are we going to start? I'll give you a hint. Now what? 3,500, yep.
Present. So multiply, right?
Yep.
That's great. Thanks for contributing that.
There you go.
0.05.
1 plus 0.05. Divided by 12. To the power of 300 minus 1. Okay. Yep. Open.
1 plus.
Perfect. Now we can close and close. Remember, when we're drawing out, we always have that extra term there. So this is going to give us how much Sammy needs at 66 to cover her retirement. So $598,710.16.
Looks right.
Now, that's what she needs to cover retirement, but she needs $30,000 more to cover the move. So she's going to need I don't know why I put that extra comma in there. I'm thinking millions. You're rubbing off on me. So $628,710.16 is what's going to be needed at the end of the savings. So at 66, that's what Sammy needs to have saved up. So now we're going to use that to start our accumulation phase.
And then you twist free, right?
And then we're twist free, yes. That sounds like an end of a very painful era. So 40 years is 480 months. So yes, we take that amount divided by 3 open parentheses, 1 plus 0.11 for the 11%, divided by 12, close to the power of 480, minus 1, close, divide by open, 0.11 divided by 12, close and close. $73.10.
Always put the exponent outside of the parentheses.
Yes, it always goes outside the parentheses here. Okay, now XA, XB, and XC are problems similar to ones that I have done in class. I did one in class where we drew out money partway through for payments on to make a down payment on a house. I did one in class where we're paying in annually and compounding monthly or compounding quarterly. Remember, what you have to do is the effective rate. I am going to give you a hint on EXC. And the hint I am going to give you is you need to find the effective rate of 8.6% compounded monthly. The question is for how long? Well, how often are the payments made?
Quarterly.
Quarterly, and a quarter is how many months?
3 months.
3 months. So you need to find the effective rate of that 8.6% compounded quarterly for 3 months. So I use $10,000 for effective rate. So that's going to be times 1 plus 0.086. It's divided by 12 because it's monthly, but only to the power of 3 because it's 3 months. You'll find that amount, and that's what you're going to use for your effective rate calculation. Once you have that effective... Oops, go ahead.
Did you mean to put 12 when you divided by 2? Did you mean to
Yep,
put
my
that
one
12?
didn't show up, or I forgot to put it in there. One of the two. Divided by 12. You are correct. And then once you have that effective rate, which will be higher than 8.6%, so we are just going to call that ER right now. You are going to then use that with the $500 monthly or quarterly payment divided by 4 because it's going to be quarterly to the power of the number of quarters. Okay? You guys have fun with these, and I tell you what I'll do, since 3, 4, and 5 are all pretty difficult as well, I will bump it up, so 3, 4, and 5 will be worth, let's make them each worth 6 points. But I won't go over 37 points for the whole worksheet, just so you know. Yes, I'll take that. Those of you that are here, if you do want to leave your test corrections so I can verify them. No, just leave it.
50 marks.
So you want to
Did you not just tell me no?
Well, you didn't see his breakdown.
You just told me no.
That's true.
Did I? I'm sorry.
Yeah.
So
It's
each
that
one's
point in the
gonna be
year.
C.
Each one is.
Thanks.
But if you needed a C minus because you needed to pass further.
Thank you.
So it's
Thank you.
C minus.
We'll see you next fall.
77.
You bet. Have a good one. Thanks, sir.
Doug, do you keep getting more courses in business